Okay, so we are now going to go over the next section of the 3.2a CFA, and we're going to start with questions 13 and 14. And so this looks a little bit different than it does on your CFA, but it's still the exact same questions. It's just formatted differently. And so we are starting out with, we've got phosphoric acid, that's the H3PO4, reacting with barium hydroxide, BaOH2, and we need to predict what, when this reacts, what it's going to make, and we also need to balance the equation and say what the reaction type is. And I'm going to actually go and do the reaction type first. And so since we've got right here, we've got H3PO4, which is hydrogen, which forms like a positive ion, bonding with phosphate that is a negative ion, and then you have barium that's a positive and hydroxide that is a negative. I know right here that I have a double replacement reaction in front of me, and that the hydrogen and the barium are going to switch places. And so our reaction type here is double replacement, DR. And so since I know that the hydrogen and barium are going to switch places, I know that I am going to end up with H bonding with that OH, which you can also write that as H2O because that is the same thing, right? An O and two H's. And then and then we have to think about, okay, like are the charges balanced in this? If hydrogen is a +1 and hydroxide is a -1, we are already good to go. We are already balanced. And then next we have now the barium is going to be with the phosphate. And then we need, that's a 4. We need to think about what the charges are on each of these. And so barium is a +2 and phosphate is a -3. And so in order to make the charges balance in this compound, we need to add a 3 right there to the barium and then a 2 outside the phosphate. I'm going to fix that 4 because it looks kind of wacky. Erase. There we go. I can do it. There we go. That's better for. Okay. So now we have the reaction type and we've predicted our products. Both of our products are balanced in their charges, but our equation itself is not balanced. And so we need to do that. And so I'm just going to write over here, split, like right, actually, no, undo. I can do it actually right here that we're going to line up with what we have up here. So we are dealing with hydrogen. We're dealing with phosphorus. We're dealing with oxygen. And then we are also dealing with barium on each side of our equation. All right, so counting up what we see on each side. In our reactants, we have 3 hydrogen here, and then we have 2 right here. So that is going to be 5. We have 1 phosphorus. We've got 4 oxygen here, and then 2 right here. So that's going to be 6. And then we have 1 barium. And then on our product side, we have 2 hydrogens right here in our HOH, which is, so that's a 2. Phosphorus, we have 2 phosphates right here. And so that is going to be a 2 there. Oxygen, we have 4 in 1 phosphate, but we have 2 of them. So that's 8 plus 1 more. That's going to be 9. And then we have 3 barium. And so a good rule of thumb practice when balancing is to, if you have a polyatomic ion, to go and try to balance that first. And so I'm going to try to get the phosphorus balanced, or the number of phosphates balanced on each side. And so we have 2 here, we only have 1 here. And so I'm going to see what happens when I put a 2 in front of that phosphoric acid at the beginning. And then we're going to need to recount and see what that turns it into. So we have 2, I just zoned out. Okay, 2 times 3, which is 6, plus 2 more from here is going to be 8. And then phosphorus, we now have 2. Oxygen, we have 2 times 4, which is 8, plus 2 more, which is 10. Our phosphorus now balanced on each side. Now I'm going to try to do the barium. And so I have 3 bariums in our products. And so let's change that to be a 3 in front of that barium hydroxide. And so now we have to recount our H's, our O, and our Ba. And so H, we now have 6 as part of the phosphoric acid. And then we had 2 hydrogen and we just made that 3. So that 6 plus 6 is going to be 12. Our oxygens, we have 8 as part of the phosphoric acid, and then plus 2. Oh, wait, sorry. Okay. 8 part of here, and then we had 2 times 3, so now that's 14. And then barium, we now have 3. So looking at this now, we have a lot more hydrogen in our reactants than in our products. So I'm going to look at this HOH right here, and I'm going to think, how many of these molecules am I going to need to balance out our hydrogen? And the answer there is going to be 6. So let's see how that changes things, changing our hydrogen and our oxygen. So hydrogen, we now have 12, which is what our goal was. So that's good. And then oxygen, we had 8 as part of our barium phosphate already, and we just added 6 more. And so that is going to be 14. If you look at this now, we have 12 hydrogen on each side, 2 phosphorus on each side, 14 oxygen, and 3 barium. So our equation is now balanced, and that is our final answer. I can erase the charges that I wrote. There we go.